Hi, I'm Andrey Kutuzov, and this is a joint work with Jeremy Barnes, Eric Weldel, Lila Overlid, and Stefan Open from Language Technology Group, University of Oslo. I'm going to talk about our project in training and publishing large-scale contextualized language models for Norwegian. This is the so-called NorELMo or Norwegian Language Models project, which is available at the webpage norelm.nlpl.eu. And essentially, this is an emerging collection of large-scale contextualized pre-trained language models for Norwegian. This is a community initiative under the umbrella of the so-called Nordic Language Processing Laboratory, or NLPL, which includes European Open Science Cloud and the Sentiment Analysis for Norwegian project. And as I've said, it is coordinated by the Language Technology Group, LTG, at the University of Oslo. The aim of this project is to provide models and supporting tools for NLP practitioners for Norwegian, and in this particular talk today I will talk about some of the models that we have made available just recently. The core of the NorELMo project is the so-called NLPL vector repository, which is publicly available storage of pre-trained distributional models for different languages, including about 70 models for Norwegian. And this includes good old static embeddings like what2vec, glov, fastText, etc., LSTM-based contextualized embeddings like ElMo, and transformer-based contextualized embeddings like BERT. It is important that we provide not just pre-trained models, but also everything necessary for their training, and this is what we call the NLPL virtual laboratory. So we have developed a fully automated modularized installation procedure using the well-known Easy Build framework, which allows one to automatically create like fully parallel, fully reproducible training and experimentation environments on different computing infrastructures. And currently we have made available these kind of environments on the Saga supercomputer cluster in Norway and on Puhti supercomputer cluster in Finland. But we are also expecting the European LUMI supercomputing cluster to come into usage in the end of this year to make our virtual laboratory available on LUMI as well. Essentially, our virtual laboratory allows one to quickly go on from almost raw Linux operating system to fully optimized custom-built TensorFlow and PyTorch and other NLP-related tools which are optimized for a particular hardware platform in just a couple of commands, and you can try that using our Git repository. And this project is also a part of the NLPL collaboration, which aims at allowing cross-border academic access to high-performance computing clusters in Nordic countries. So yeah, what models have we made available, and what models have we trained and evaluated recently? Let's start with NorBERT. Until recently, the only BERT model available for Norwegian was the Google's multilingual BERT, or MBERT. And this was not enough, and thus we trained our NorBERT model from scratch on Norwegian data, essentially following the workflow which was used by the creators of Finnish BERT. And an important thing here is that our NorBERT model features a custom 30,000 sentence piece vocabulary, which ensures correct Norwegian tokenization. So let's, for example, try to tokenize the sentence that the Norwegian sentence that you see on the slide using Google's multilingual BERT. This will be something like that, and you can see that this tokenization does not make much linguistic sense. So morphemes are split, and it is obvious that the model doesn't have many Norwegian words in its vocabulary. At the same time, NorBERT splits the same sentence in a much more coherent way, which is important for anything, for any research which tries to be linguistically informed, and for any research which tries to kind of to study anything linguistically related. The NorBERT model is available both as a separate download from the NLPL vector repository, and also as also can be used and downloaded from the Hugging Face model hub. The training corpus for NorBERT is a joint corpus consisting both of Norwegian bookmodel and Norwegian Nynorsk texts. Norwegian has two language varieties, as you probably know. And this corpus is about 2 billion words in size, in about 200 million sentences. And it consists mostly of two parts. The so-called Norskavis corpus, or Norwegian news corpus, which contains news texts published in the time period from 1998 to 2019. And the second part is bookmodel Nynorsk Wikipedia dumps from September 2020. So our corpus consists mostly of news texts and encyclopedic texts. Before training, the texts were sentence segmented using stanza, so that the next sentence prediction task in BERT worked correctly. And the model architecture was essentially identical to BERT base, 12 layers, each layer of size 768. And we used the BERT implementation by NVIDIA, since it allows efficient multi-node and multi-GPU training. The model was trained on Norwegian National Saga supercomputing cluster, and the training took about 3 weeks using 4 compute nodes with 4 NVIDIA P100 GPUs each, so 16 GPUs in total. All the code that we used to train the NorBERT model, all the patches that we applied to the NVIDIA code are available in our GitHub repository, and we also have documented the whole process in the wiki page. And in this slide, you can also see a nice puffin, which is the mascot for NorBERT. Okay, so the training workflow in general was quite standard. As usual with BERT models, it was divided into 2 phases, where one phase used the maximum sequence length of 128, and the second phase used maximum sequence length of 512, and slightly less batch size. This was pretty standard. But we're not limited to only transformer-based models, and we also provide some ElMo models for Norwegian. As you probably might remember, ElMo was the first well-known successful contextualized embedding architecture, which got the Best Paper Award at the NACL 2018. And unlike transformers, it consists of 2 layers of bidirectional LSTMs. And it's important that the memory and the training time requirements of ElMo are much more relaxed than transformers, but at the same time, in many cases, it can deliver almost comparable performance, as I will show in a few minutes. So we provide a set of ElMo models for Norwegian. In particular, the so-called NorELMO 30 and NorELMO 100 models, which are trained on the same corpus as NorBERT. And the only difference between these 2 models is that the first one is trained with 30,000 words in the target vocabulary, and the second is trained with 100,000 words in the target vocabulary. They were trained with 3 epochs, batch size 192, so all the parameters were pretty standard. The dimensionality of the LSTM layers was set to 2048 instead of default 4096, which in our experiments does not hurt performance in most cases. Importantly, these are the first full-fledged ElMo models for Norwegian. A couple of years ago, the ElMo for Many Lungs project has released a bunch of ElMo models for different languages, including Norwegian, but they used very small corpora, and in our experience, these models downperform in semantic-related tasks. So these models, the NorELMo models, are released as TensorFlow checkpoints and as HDF5 files. They are fully self-contained, include the vocabularies on which they were trained, etc. And we also offer a Python module which is called Simple ElMo, which uses TensorFlow under the hood and which can be used to extract contextualized embeddings from pre-trained ElMo models. So it really makes it quite easier to work with the models that we released. Right. In addition to that, we have also implemented the so-called ElMoViz web service, which is essentially a web-based platform which allows the users to enter a Norwegian or English sentence and then get the so-called lexical substitutes for each word in this sentence. You can think about that as some kind of contextualized rephrasings of the input sentences, and this can be used both in the classroom when you teach your students just how the pre-trained contextualized language models actually work, or you can use this service to explore different contextualized models and to find out how different they are. So the lexical substitutes which are produced by this web service are, of course, contextualized, meaning that they will be different for the same word in different contexts. Let's move on to the evaluation part. Concurrently with our work, another BERT model for Norwegian was released, the so-called NorBERT, which was produced by the NoTram project in the National Library of Norway. This project is also presented at NorDALIDA this year. The NorBERT model is trained on 10 times more data than NorBERT, so the National Library, of course, has access to much more text than we do. But however, this corpus is mostly OCR'd books, which means at least some amount of noise. And also, NorBERT is not trained from scratch. Instead, it is initialized with the multilingual BERT weights, which means that it has the vocabulary of 120,000 subword pieces, most of which are not Norwegian. This also means that when you fine-tune NorBERT, it is somewhat slower than NorBERT because the vocabulary is larger. So yeah, let's compare these models. We evaluated them on a selection of standard NLP tasks for Norwegian. You can find more details in the paper, but essentially for all the tasks, part of speech tagging, sentiment analysis, named entity recognition, we found out that the models trained on Norwegian always outperform multilingual BERT by Google. In some tasks, like for example in part of speech tagging and in named entity recognition, the NorBERT by the National Library outperforms our NorBERT, even if marginally. But in some tasks, for example in fine-grained sentiment analysis, they are completely on par with each other. At the same time, we can see that NorBERT usually takes less time to fine-tune. And the same is true for the ElMo models, which sometimes can be like 2 orders of magnitude faster to fine-tune, and the performance at the same time is almost comparable to the performance of the transformer-based models. So we think that NLP practitioners can actually choose what models to use in every particular situation. Okay, so what's next? We are aiming in the future to develop a comprehensive benchmark sets for Norwegian. We're also planning to collaborate with the National Library of Norway to train more models on larger corpora, so like to work together on that. We would like to train separate models for bookmall and NUNORSC and evaluate them on different subsets of the available corpora. There is an ongoing effort on training joint Nordic models on several Nordic languages like Swedish, Norwegian, Danish, Icelandic, etc., etc. And finally, we also would like to train more resource-heavy models on the Lumi supercomputer later this year, like Roberta, Electra, T5, etc. And also we have some ideas about using linguistically motivated inductive biases during the training, which we hope will improve the models even more. That's it. Thank you for your attention, and questions are welcome.